Okay, so you're looking at a bunch of half reactions. Now, if you pick out any particular one, I want you to notice they've done you a giant favor. They're all balanced for you by mass and by charge. Now, do you see those numbers in the middle? Okay, those numbers are going to be useful to us later because they tell you the tendency of the half reaction to take place. Now, look in the middle where they mention they have hydrogen. You notice that zero? It's deceiving. That doesn't mean hydrogen doesn't take place. This is a relative scale. Matter of fact, hydrogen is more likely to take place than any ones below it. They probably should have made the bottom one zero and then made the rest positive numbers. By the way, you notice that lithium has the biggest tendency to take place. That's why we use lithium batteries these days, because lithium is a great electron donor. Now, there's something slightly wrong with the table, though, and I'll reveal it. By the way, put this one to the side because we're going to use it in a moment. So put this to the side. But I want to show you what's wrong with this table. The problem with this table is it ain't no good. No one's ever figured out how to get one half reaction to take place. It just can't be done. So from that point of view, the table is useless. You're looking at a bunch of things that can't take place. So let me show you how we're going to remedy this. The trick is you can't get one half reaction take place by itself, so therefore you have to pair that up with two half reactions. Now, as an example, I decided to pick barium half reaction and aluminum half reaction. Why don't you look on your table and see if I've copied them correctly? Because if I copy them correctly, the table is doing you a giant favor. They're balanced by mass and by charge. Now, to get something useful, though, we have to take one of these and reverse it. So you notice I decided just to reverse the aluminum half reaction. Now, here we have two balanced half reactions, but to make something out of it, we have to get the electrons to cancel out. So what do the numbers 2 and 3 suggest you for electrons? Switch the numbers. Why don't we take 3 for the barium and 2 for the aluminum? So a useful reaction would be 3 bariums plus 2 aluminum plus 3 will give you 3 barium plus 2 and a 2 aluminum 0. And as double check, notice it balances by mass. 3 bariums, 2 aluminums, 2 aluminums. And how about the charge balance? 2 times 3 would be plus 6, and 3 times 2 would be plus 6, yeah. Now, this is a relatively small table. The Handbook of Chemistry and Physics, I think there's 3 pages of these. Since this is so small, what I want you to do for a homework assignment is come up with all the possible combinations of reactions you can get. That's a joke. Why do you think I'm kidding? The point is, look how many reactions you can make out of this very, very small table. It's kind of amazing, so it really summarizes a hell of a lot of information, even though it looks kind of small. Okay, I'd like you to look at this bottom reaction now, because it's one that worries me. About once a year, I have to go to downtown Los Angeles and do some business, and here's what worries me. The air in downtown Los Angeles is very smoggy, and one of the ingredients is ozone. I've heard that ozone is so powerful it can actually react with gold. And I'm always worried that the ozone is actually going to dissolve my gold rings. Now, here's what I want you to do. I want you to look at the half reaction table and see if you can complete the reaction between ozone and gold. Now, what you need to do, I'll give you a hint. Look low on the table. If you look low on the table, you'll find a half reaction with gold in it, and you'll also find a half reaction with ozone in it. Now, you've got to switch one of the two around, but see if you can come up with a reaction where you have ozone and gold on the left, and then see what the products will be on the right. So let me give you about 1 minute to see if you can do that, and then I'll show you my solution. No? Okay. All right. Let me show you what I came up with. So what I found is, I found this gold half reaction. It's actually the third one from the bottom. So I just copied that one as it. It said gold metal will form gold ions and give off 3 electrons. Now the ozone one's a little bit harder to find. Look at the second from the bottom half reaction, and you notice that you have ozone on the right-hand side. In a way, that's good because we know we have to flip one reaction around. Remember, when you pair these up, you're going to keep one as it is and flip the other around. So if I flip the ozone half reaction, that's good because I get electrons on opposite sides. So the ozone half reaction said ozone plus hydrogen plus 2 electrons gives you blah, blah, blah. Okay, so what I need to do then is to get the electrons to cancel out, I need to double the top one and triple the bottom one. And so I got 2 gold reacts with 3 ozone plus 6 hydrogens, give you 2 gold ions plus 3 oxygens plus water. Okay, now here's the significance. I found out, yes, unfortunately, gold does react with ozone. But I learned something really good. That reaction cannot take place unless you have acid present. So if I can keep acid out of the um, problem, don't put any acid on my rings, the reaction will not take place. I want you to notice if it does take place, though, maybe there's some acid in the air, it isn't the end of the world. It's true, my gold ring will dissolve. So gold plus 3 is dissolved gold. But it's not the end of the world because notice the other products. If I have trouble breathing, I can breathe the oxygen given off my ring. And if I get thirsty, I can drink the water that's produced. So it isn't the end of the world. So the point is you can really learn a lot. You can be creative. You can pair these together and learn a lot by just taking two and shifting one around, and you can actually create your own reaction. So it really is a very, very valuable table. Okay, so the lesson is over, except I want to give you a homework assignment. Okay, so on page 190, problems 97 and 98, they give you a bunch of redox equations, and they ask you just to identify the agents. So that's good practice for the agents. Now, 931 is the biggie, though, because these are problems to be balanced. Now, if I was going to say, God, this Berg, you're only giving us, 37 to 42, what is that, 5 problems? I think each part has about 5 different ones. So there's about 30 problems you could practice. So if you can do all the ones on page 931, you are an expert at redox balancing. And again, my suggestion is try the half reaction method first. I think it's the better method. And if it fails, try the oxidation number method.